Welcome to Lesson Plan 2, which is called Load and Display an Image. This lesson plan is one of a series of 6 that will take you and your students from no programming experience to a simple multimedia app in 6 steps. In this lesson plan, you will learn about global variables, how to pass information to library functions using parameters, and learn how to use return values from library functions. Please do take a moment to send us feedback on this lesson plan. If you think that it can be improved, then please contact us at the email address support@yousource.com. In each lesson plan, we provide you with a summary slide like this, outlining the learning objectives, new vocabulary, and resources you will need. For this lesson, you may want to have a published image in your teacher workspace, like a school logo or a well-known local site, which the students can use as an image to load and display in their app. We propose an organisation of activity, but of course you can structure your lessons how you like. Some ideas around structuring the plenary session and assessment are also provided. In each lesson plan, we also provide a list of new words and their definitions in the vocabulary section. If any of these are not clear, then please do get in touch with us so we can improve these definitions. Before we get on to the lesson plan, here are some notes. Think through how long you think this lesson plan will take with your students, depending on their age or ability. There is quite a lot of scope for extending this lesson, depending on whether you let your students find an image they like on the internet and upload it in their workspace. We want to get on and do something visual in this lesson, but we're not doing error checking in the code yet, so students will have to type very carefully. If they type the image name incorrectly, then the image won't load or appear. There are already images they can load without you or them having to upload one, so I suggest you start with the YOUSRC logo that we provide and go from there. If you have a chance to prepare, then as a teacher you can upload an image into your workspace. Something local or relevant to the students. For them to load it, it needs to be published. But as a teacher, you can do this yourself using the Publish button in your Images Workspace tab, and it will be published immediately with no further review by us. That's part of your teacher privileges. If you have time in your lesson, then let the students find an image on the internet and upload it to their workspaces. An image only needs to be published if it is to be loaded by someone else. The person who has it in their workspace can use it in their apps whether it is published or not. When an image is published, we check it and will reject any images we find unsuitable or unsavoury. The image formats that can be used are set by the Java runtime that we use. We can use what it supports. Actually, Java supports most image formats, including JPEG, lots of colours and good compression, so good for larger images or photos, and PNG or GIF. Fewer colours, but supports transparency. We find that JPEG and PNG images work best. Note that if a PNG or GIF has transparency in the image, then that transparency is also shown when the image is loaded into an app. An animated image will not animate in an app. To do animation, you will need to load each frame as a separate image and cycle through them, which is beyond what we are doing in this lesson. From here on, I will use language that means you can use this video either for your own lesson preparation or in a class with students. Here's a quick summary of what we did last time. We learnt to log into YOUSRC, access our workspace, create, edit, check, and run apps. We wrote an app to display the Hello World message on the screen using the library function called gfx.writeLine. We controlled the timing of the messages using a library function called timer.sleep. So we were writing code looking a bit like this. In this lesson, we are going to write an app that can load and display an image on the screen. To do this, we will get the app to load the image, remember the image we have loaded using something called a variable, draw the image in the position we want it, refresh the display to see it on the screen. First, there are some rules about where you can load images from. The first place you can load an image from is the freely available images that YOUSRC provides. These are shown below your images in your image workspace. To load an image, you will need to use its full name, which is the image owner, in this case YOUSRC, followed by a colon, followed by the image name. So a good example to get started with is YOUSRC : logo, all lowercase. The second place you can load an image from is your image workspace. This stores any images you upload yourself. To load the image, you will need to use its full name, which is your YOUSRC account name, followed by a colon, followed by the name you give the image when you uploaded it. Nobody else can use an image in your workspace until you publish it using the Publish button. Finally, the third place you can load an image from is anyone else's published images. So if your friend or teacher uploads an image and publishes it, then they might tell you what it's called. Alternatively, if you see any image in anyone else's app published from the showcase, then you can look in their code and use their YOUSRC name, colon, image name to use their images, because all images used in published apps are themselves published. An example is Rachel C, rabbit, which is used in the app called Put the Hat on the Rabbit. Let's take a closer look at publishing an image. Here you can see how an image is shown to you when you look in your images workspace. At the top is the name of the image in the form you would use it when loading it, which is the YOUSRC name, colon, image name format. Below that is the image itself. To the right is some information about the image and 3 buttons. The first button is used to delete an image, which is only possible before an image is published. The second button is used to publish an image. The third button is used to rename an image, but this too is only possible before an image is published. Please note that after you click the Publish Image button, we will check that your image is suitable before approving it. We will not approve any images that are rude, nasty, or too scary. Loading an image is very simple. In some programming languages, this would take lots of lines of code, but in ELC, we can do it in just one line called gfx.imageLoad. This is passed one parameter, a bit like gfx.WriteLine that we used in the last lesson. You pass it the full name of the image, like YOUSRC logo, inside the quotation marks, like our Hello World message. The gfx.imageLoad library function creates a connection over the internet to our YOUSRC servers, which are whirring away in a data center near London, and loads the image into your app running on your computer. Typically, this is done in a fraction of a second, but of course that depends on the size of the image and how busy your school's internet connection is. Let's have a go at loading an image. It won't appear on the screen yet, as we haven't positioned it, or refreshed the screen, but we can still load the image as a first step. The code consists of a start function, like last time, and there are 3 lines of code in the function. The first line displays a message saying what we are doing, which is loading an image. The second line loads the image using the gfx.imageLoad library function. Here we are passing it the full image name of the YOUSRC logo image. Finally, the third line displays a message saying that the image has loaded. Loading can go wrong. For example, you could spell the image name wrong. As we have not yet taught you how to check for errors that occur on runtime, please do type the image name carefully. Now let's do this for real in a browser.
Thanks, Emma. So let's look at the YOUSRC website and let's create an app that will load an image. So first thing we do is go to our workspace and create a new app called Load and Display an Image. Okay, so here's the app control screen. We haven't put a thumbnail in yet, so it's just going to leave us with the default thumbnail. That's fine for now. Let's edit the source. First thing I'm going to do is update the comment so we know exactly what our app does, and I'm going to change that to load an image, don't display it yet, because all we're going to do for now is do the loading, and we're going to put in our 3 lines of code. The first one was gfx.WriteLine loading image. So we're going to tell whoever's running the app exactly what we're doing. The next line of code is going to load the image. So that's gfx.imageLoad, and we put in the name of the image, YOUSRC logo, in side quotation marks, and then we're going to tell the user what we've done. gfx.WriteLine image loaded. So those are the 3 lines of code. and let's check that. The checker starts, and as you can see it says everything's alright. So now we're going to run that app, and what I want you to look for is the very slight delay between the message loading image and the message image loaded. And in that slight delay, the app running on this PC is going to talk over the internet to the YOUSRC servers and load the image. There. So hopefully you saw about a half-second delay. I'll do it again between those two messages. There. Happened to be a bit quicker that time. It all depends on the speed of the internet at the time you run the app. So there we have it. I'll go back and just show it to you again in the editor. There's our code that Emma's just taken us through, where we say loading an image, we do the image load, and then we confirm the image is loaded. Back to you, Emma.
Computers are good at remembering things, and we now need the computer to remember this image so that we can position it and see it on the screen. Computer programs remember things for us using something called a variable, which is named after a place in its memory that can vary or change. We will be using a variable to remember the images we load, but lots of games will also have variables for things like game score, positions of goodies or baddies, how many lives are left, etc. If you're new to variables, then a good way to think about them is a shoebox with a name on the front. You can store a piece of paper with a number in the shoebox and retrieve that piece of paper to see what the number is whenever we want. The name on the front of a shoebox allows us to remember lots of things and know which is which. If I name a shoebox score and another lives, then when I want to know the score or the number of lives left in the game, then I can check the right shoebox. You can call variables pretty much anything you like, but there are a few rules. Variable names have to be unique, so you can't have more than one variable with the same name, and variable names can't have spaces in them or start with numbers. Sometimes people use a mix of uppercase and lowercase to make variable names more readable, such as this: number of lives, example here. The names are case sensitive, so you need to always spell them the same and use the same lowercase and uppercase and letters whenever you use them. So pick a style of naming variables that works for you. Ideally, something short, clear, and easy to read. To use our image, we need the computer to remember our image when we load it. To do this, we create something called a global variable. The global bit means we tell the computer about it before the start function and use the global keyword. The global variable can be used to store a number or fetch it back from anywhere in the app. Telling the computer about a new variable is called declaring it to the computer. Here we have declared a new global variable called myImage, and we've used capital M and I to help us read the name. So now, using our shoebox analogy, we have a shoebox called myImage written on the front, but we haven't stored anything in it yet. Let's take a closer look at library functions. We've already met library functions when we used gfx.writeLine and timer.sleep in the first lesson, and now gfx.imageLoad in this lesson. These do powerful things for us to keep our code simple. They are named library functions because it's a bit like a library, but instead of lots of books to choose from, you have lots of functions to choose from, depending on what you are trying to do. Some library functions do something simple for us on the computer, like timer.sleep, which stops your app for a period of time. Other library functions change something about the app, such as gfx.writeLine, which displays text on the screen. But many of the more powerful library functions need to tell our app some information, either something about the computer, such as where the mouse is or if a button is pressed, or some information they have fetched from the YOUSRC service for us, such as when we load an image. When a library function needs to tell us something after it has done its job, then this information is called a return value. An example of this is the gfx.imageLoad function. After loading the image into the app, it needs to give us back an image number. It's a bit like the computer saying, "Okay, I've loaded the YOUSRC logo and given it an image number of 1, so when you want to do something with the image, tell me to use image number 1. Perhaps another image in your app would be image number 2. When we come to position the image, we tell the computer the image number we want to use, and in this way, the computer knows what image we are talking about. In the ELC language, The way a library function gives us a return value is to store it in a global variable set up by the computer called retval, which is short for return value. So in our shoebox analogy, the computer has written retval on the front of the shoebox, and when it needs to give us some information, it puts the information in the shoebox, ready for us to fetch and use. To explain this further, let's look at the code. Here we have added one more line of code after the gfx.imageLoad library function is called. We now know that the gfx.imageLoad library function will put the image number into retval in order to return it to us. As retval may be used by other library functions later to return more things to us, we should take a copy of what's in retval and store it in the variable we declared earlier called myImage. We do that using the let statement. The line let myImage equal retval fetches the value stored in retval and stores the same value in the myImage variable. In our shoebox analogy, it's like looking in the retval shoebox, reading what's on the paper written inside, writing the same number on a new piece of paper, and putting that piece of paper in the myImage shoebox. Let's see this in the browser.
Thanks, Emma. So let's create this new global variable, and then after we load the image, let's store the image number in that global variable. So to do that, back in the editor, I'm going to add the line global myImage, and I'm using a capital M and a capital I just to make it a bit easier to read, but as we've already seen, you can call your variables pretty much what you want. Now, the next thing we need to do is after we load the image, we know that gfx.imageLoad will store an image number in retval. So I want to take a copy of that, so I add the line let myImage equals retval. And what that will do is take a look at what retval is and put a copy of it in myImage. And that means later on, when we want to start positioning images, we will have a store of the image number that we can use in those library functions. So we'll see those later. So now let's save and check that code. Looks good. And let's run it. And as before, all you can see is loading image, image loaded. So if we want to see a little bit behind the scenes of what's happening here, I'm going to run that in the debugger. Just let that load. Now let me just get this positioned so that you can best see what's going on. Over to the right of the debugger, I've got a button here called Start Watching Variables. I'm going to press that, and that now shows me the variables that the system is aware of. So if I run highlighted line, the code is now starting, and the debugger knows that we're in a function called start. And if I run this line, then over on the left hand side we've now displayed the text loading image. Now I want you to look carefully at what happens when I run GFX image load. Under this variable list you can see our variable called retval, and at the moment it is 0. But when I run this line of code, GFX image load, I expect retval to be set to an image number. So let's see what happens. Watch this number here on the right, retval, carefully. So there was a slight delay while the image was loaded, and you can see that retval was set to 1. So the computer has assigned image number 1 to this image. We've got our global variable up here called myImage. That is still just left with 0, which is what it was when the app started. But when we run the next line of code, let myImage equals retval, we know that the computer will take a look at retval, see what value it has, and then store that value in myImage. So when I run the next line of code, if you watch carefully over here, we should expect myImage to be set to the same as retval, which is 1. Here we go. There. So you can see that running let myImage equals retval set the variable called myImage to 1. Let's finish this off then, run the next line of code, which is gfx.writeLine image loaded. So over here, when I run this line, we see our line of text. And so there we've run our code, which creates a new global variable and stores a copy of the image number in that global variable after GFX image load. And we've used the debugger to see inside how the app runs line by line. So I'll go back to the editor, and I'll pass you back to Emma.
Okay, so we've loaded our image and we know how to store its image number in a variable. It's now time to draw it and update the screen to show it. Before we do this, there are 3 things you should know. YOUSRC apps start in text mode, which allows you to easily display text using gfx.writeline. Once you display an image, it will go into graphics mode, which hides your text as the graphics are shown on top of the text. Once you display an image, you won't see any further text you write underneath the images. Images are not automatically shown on screen as soon as you position them. This is because games would be very flickery if the screen updated after each image draw. Instead, to get smooth games, you position all your images and then refresh the screen. To position images, we need to have a quick look at the screen coordinates used in YOUSRC apps. This is shown on the next slide. This slide shows the YOUSRC app screen in graphics mode. There's a faint background of diagonal ELC letters in grey on a white background, which is automatically drawn for you to hide any text you may have displayed. Images are placed using X for horizontal and Y for vertical coordinates. The origin, where X is 0 and Y is 0, is at the top left corner of the screen. The screen is 480 pixels wide by 360 pixels high. When you want to position an image, you need to work out where the X and Y coordinates should be for the top left corner of the image. Lots of games use many images which overlap each other, like a helicopter flying over a desert in the Desert Attack app. The way you set the order of what overlaps what is through the order you load the images using gfx.imageLoad. Load images in the order you want them drawn, starting with the bottommost image and working your way up. In this example, we are just using one image, so we don't need to worry about that. So let's add the line of code to position the image. But remember, this will not update the screen yet. The library function to position an image is called gfx.imageDraw, and we need to tell it 3 numbers or parameters in the right order. The first parameter is the image number, our way of telling the computer which image we want to position. Remember, we are given this as the return value from gfx.imageLoad, and we stored it in our variable called myImage. The second and third parameters are the coordinates, where we want to position the image. The second parameter is the x or horizontal coordinate, and the third parameter is the y or vertical coordinate. Here I'm using the x coordinate of 50 and the y coordinate of 100. Now we want to see our image, so let's add our last line of code. The library function to refresh the screen is gfx.show, which takes no parameters. Let's see this in the browser.
Thanks, Emma. So we're going to make our final changes, and this will now get the image on the screen. So the first thing we want to do is add our gfx.imageDraw line. So that goes in here. gfx.imageDraw. We need to tell gfx.imageDraw which image we want to draw, and we know we've stored that in myImage variable. And then we need to specify an x position, and we've said 50, and a y position 100. And then to actually get the image on the screen, we use gfx.show, and that will refresh the display. Our comment is now looking a bit out of date at the top. Load an image, don't display it yet. We need to change that. Load an image and display it. Okay, so we've added these 2 lines. Let's now check it. That looks good, and let's run it. And there's the YOUSRC logo. We've loaded it and we've displayed it at 50 on the x coordinate and 100 on the y coordinate. Just to prove to you what's happening, let's change the x coordinate to 100 as well, and we would expect it to be more on the right. So we just change that to 100, 100. Save and check that. And run it. There you are, and now you can see that the x position has now gone to 100 and the y position is still 100, and so the YOUSRC logo is now displayed more to the right. Back to you, Emma.
Here are some exercises to help you think about what we have done and extend these ideas. that's the end of the second lesson. You've loaded an image and stored the image number in a global variable. You've positioned the image at the place of the screen where you want the image drawn, and you've caused the screen to refresh to show the image. I hope that was fun. Congratulations on loading and displaying an image, and please try lesson 3, where we will get the image moving.